Hello viewers, welcome to the session on hierarchical clustering in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. So let's quickly look at the definition of hierarchical cluster in machine learning. Hierarchical clustering is also known as hierarchical cluster analysis. It is nothing but an algorithm that groups similar objects into a group called clusters. Here, the endpoint is a set of clusters where each cluster is distinct from each other cluster and the objects within each cluster are broadly similar to each other. Confused? Don't worry. Let's understand the same definition in the form of a graph. So, here I am having a graph where we are having objects without clustering. Now, after clustering, I am having a set of clusters where each cluster is different from another cluster and the objects within each cluster are broadly similar to each other. Let us now look at the formula that we use in hierarchical clustering. The main formula which we use here is Euclidean distance between point P1 and P2. It is nothing but under root of x2 minus x1 whole square plus y2 minus y1 whole square, where x1 and y1 are the coordinates of point P1 and x2 and y2 are coordinates of point P2. And the various criteria through which we form cluster here are closest point distance, average distance, farthest point and distance between centroid. Let's look each of this with visualization. Let us suppose I am having clusters like this, I am having objects like this and I want to make them into a cluster, a simple cluster. So the basic criteria that I can use here is first closest point distance, means the distance between two clusters considering only the closest point. Here consider the green color objects, or otherwise we can use average distance, finding the distance between all the objects and then getting the average of it and considering the cluster, or else the farthest point between both the clusters. We can consider that as our one of the criteria, and also last but not the least is distance between the centroid. The least the distance, they both get clustered into one thing. Generally, there are two approaches in hierarchical clustering. One is agglomerative and another one is divisive. Let's discuss about it more clearly in the upcoming slides. Let us look at what does agglomerative mean. In agglomerative, we use bottom-up approach and it is also known as hierarchical agglomerative clustering. It is nothing but a structure that is more informative than the unstructured set of clusters written by a flat clustering. This clustering algorithm does not require us to pre-specify the number of clusters. And it is a bottom-up algorithm in which we treat each data as a singleton cluster at the outset and then successively agglomerates each pair of clusters until all clusters have been merged into a single cluster that contains all the data. So it's a bottom-up approach. From the leaf node we try to get into the root node, and the working of the same we are going to see in the next slide. So let us now look at the algorithm that we use in agglomerative clustering. First, let's go through all these 4 points. Firstly, we make each data point a single point cluster, means n cluster. See, firstly we make each data point a single point cluster. Then take the two closest data points and make them one cluster. See, the next step. And take the two closest cluster and make them one cluster. So these two clusters are closer and we will make again one cluster. Similarly, at the end, repeat this step until there is only one cluster. So these two clusters are closer to each other, then again we cluster them into one cluster. This is our final clustering that we use in agglomerative clustering. So how does hierarchical clustering decides the exact number of clusters? For this we make use of dendrograms. Dendrograms are nothing but a tree This diagrammatic representation is frequently used in different contexts in hierarchical clustering. Because it illustrates the arrangements of the clusters produced by the corresponding analysis. And you can take a quick look of how the dendrograms look, and in the next slide we will discuss how to build a dendrogram. So let us now understand it more clearly how to build dendrogram. So from the graph we are having 6 objects P1 to P6, and we are going to build a agglomerative clustering. First we will find the Euclidean distance between all the points, and the first one we get is this one. The distance between P2 and P3 is most minimum, and so it has been clustered, and the same has been drawn here in the graph also. And now since P2 and P3 are connected, so we will extend this line. It will look like this. Then the next clustering, the next least distance is between P5 and P6, and its corresponding graph has been plotted on your right side. See, P5 and P6 has been connected. Then the next is P1 to the cluster P2 and P3. So it has been plotted like this. Here it matters the distance, and here they are joined. P1 is joined to the P2 and P3 cluster. One cluster which is having P2 and P3 objects. Similarly, the next one has been plotted here. Here we are connecting P4 to the cluster which is containing P5 and P6. See, it has been successfully connected. Again, finally, in the agglomerative, we have to keep repeating this process until we get the single cluster at the end. So finally we got this single cluster, and I have connected them. So how to know the exact number of clustering that we require? Further, we know that we have to consider a line such that it is not obstructed by the horizontal line. If we consider this, see, it is completely, we can consider a horizontal line along this axis, then the number of clusters will be 1, 2, 3, 4, 5, 6. This is maximum number of clusters. But in order to find the optimum number of clusters, then we need to consider the maximum distance between them, and we need to make sure that they are starting and ending at the same time. So when I draw a horizontal line, so the optimum number of clusters will be, it is cutting this line and this line, so optimum number of clusters will be 2. So cluster containing P4, P5, P6, and cluster containing P1, P2, P3. So after understanding agglomerative clustering, let us understand divisive clustering. It is much simple, just the reverse and inverse of agglomerative clustering. It is also known as DIANA, which stands for division analysis. You can see from here, in agglomerative hierarchical clustering, we used to start from the single object, and we used to do clustering and then reach into one single clustering. Whereas in divisive hierarchical clustering, we start from one single clustering, and then we go on clustering it into smaller and smaller one up to the single object. Before moving ahead, let's analyze divisive clustering and agglomerative clustering in the same slide. Here, divisive clustering is a top-down approach, whereas agglomerative clustering is a bottom-up approach. Hope you are clear with the concept of divisive and agglomerative clustering. So now let's quickly look at the differences between agglomerative clustering and divisive clustering. When it comes to agglomerative clustering, here we use bottom-up strategy, and each cluster starts with only one object, and clusters are merged into larger and larger clusters until all the objects are in a single cluster and certain termination conditions are satisfied. Whereas when it comes to divisive clustering, here we apply top-bottom strategy, that is top-down strategy, and it starts with all objects in one cluster, and then clusters are subdivided into smaller and smaller clusters until each object forms a cluster on its own. So let's move into your favorite hands-on session on hierarchical clustering in machine learning. So in today's practical session also, we are going to work on the same dataset that we have worked on k-means. So I have imported all the important libraries. Let's quickly have the look at the dataset. See, so on the basis of annual income and CIBIL score, I am going to cluster the customers. So I have first sliced the annual income and CIBIL score and kept the same in the variable x. Now I want to plot the dendrogram to know the optimal number of clusters. For that, what I am doing is from SciPy library I am using cluster class and hierarchy. Instead of using this whole line, I am making it as alias SCH and creating an object of SCH and calling dendrogram function and passing the linkage through x and using the method of var. And I am keeping the plot title as dendrogram. On the x-axis we are having the customers and distance between them. So let me plot this so that you can have a better idea what I am saying. It's been executing. So now it has been executed. See, on the x-axis we have number of customers and y-axis contains the distances between those points. So as we have already discussed in our earlier slides, in order to find the optimal number of clustering, what we can do, first consider a horizontal line. Since this is the maximum distance that we can see, so consider a horizontal line along this line. So it is going to give 3 clusters. But when you carefully look at it, what we have discussed, this line is ending just above before these 2 lines. And so this horizontal line is disrupting this line. So what we have to consider, we have to come down and we will see another clustering. So the optimal number of clustering, consider a horizontal line along this cursor. So the number of lines it is going to touch is 1, 2, 3, 4 and 5. So 5 optimal number of clusters will be there. So for that, now let me implement the main thing. This is the main chunk of code, applying agglomerative clustering. For that, from sklearn library I am using cluster class and importing agglomerative clustering class and creating an object HC of agglomerative clustering, providing n clusters is equal to 5 and using Euclidean distance method and also linkage of a var. And after that I am storing that in a y cluster object where I am fitting those datasets and then storing it in y cluster object. Let me execute this chunk of code for executing agglomerative clustering. It has been successfully executed. So next, let's visualize the same thing, and for that I am using legendary plot to plot the graph and also labeling of 1 to 5 clusters. See, it has been successfully executed and we have got the 5 clusters here. So as usual, I have included code snippet for your fast revision. So you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.